Hello everyone, today I'm going to teach you about how to visualize the data through Matplotlib. Furthermore, I'm going to teach you why this dataset is suitable for the linear equations, and I will show you how the linear equation pattern should look like, how each other variable correlation to each other. Furthermore, I also use our own data instead of the dataset already set in the Excel to predict the final output. So without further ado, let me get started. So the first thing you need to do is you need to import the module that can visualize the data. So the module should be called Matplotlib. I mentioned just now already. Matplotlib. From Matplotlib, yeah, I always forgot. From Matplotlib, import pyplot as PLT. It's better to write the short form. So and then we also need to import this one, Matplotlib. From Matplotlib, import the style. The reason we need to import the style because we need to show the graph like a grid. Later I will show you. So the first thing you need to do is the style don't use gg block. This is the format for the grid, grid grid. And then what you need to do is plt plot, and this plot plot. So I will show you the graph, what the linear equation, the pattern look like. So because in the last video our final output is G3, so and then for the rest of the G3 is a predicted output, so I just choose one of them, G1, and then sorry, I need to use the data G1, and then so also data G3 will be the y-axis and G1 will be line on the x-axis. Y-axis will be the final output. So what you need to do is plt dot as label, or we just label down the things. What did you do? Predict the variable, and then plt dot y label. We also need to label this one. Go to G3, and then just show final. What you need to do is you need to show the graph. Yes, and then let's run. Yeah, and you see the graph like not very beautiful graph because I haven't used the we need to use the prop. So for this one, what I need to do is, you better understand why I need to use it. Yeah, so for the linear equation, the pattern should look like, hold on. So from this graph you can see that just now I label that y-axis will be the G3, the x-axis will be predicted variables. So from this graph you can see that G2 is independent variables, and then predicted variable would be the dependent variable. Why is independent and dependent? So independent, the result of the independent will based on the dependent variables. So and the linear equation graph, the pattern should look like this one, the straight line. So okay, so for this dataset is very suitable for the linear equation because the line is straight line. So even though some of the dot not is away from the straight line, because let's see the equation from this. So the dot that away from the straight line we call the error. So for example, this one is called the error. The distance between the straight line and the dot is called the error. And then so this one is called the slope. What is slope? So I know this one, the triangle one, called the slope. And then the y-intercept B will be the y-intercept. So yeah, it can be a three-dimensional, but this graph haven't touched it yet. And then for this one will be the independent variable. So the S will be independent variable. This one will be the independent variable. So Y will be the dependent variable. So yeah, so Y will be dependent variable. S will be independent variable. So yeah, I think until here you already know why this data set should be use the linear equations. So after that, now I will proceed to how do I use our own data sets to predict the final output instead of using their own data set. So what we need to do is call the predictions equal to, so what is the model? Yeah, model.fit. Okay, so I just use model because I fit the data into this one variable called model dot predict. So go to function called predict. So before that, I need to show you some things first. So show something first. Create the model first. I need to let's see model. Okay, sorry, not the models. It's data. Sorry, pardon. Yes, data. This one. So I will use our own data set to predict the grade 3. So the grade 1 will be the semester 1. We just assume that grade 1 will be semester 1, grade 2 will be semester 3. So we need to predict the semester 3, the result of the semester 3. So what you need to do is, so I just follow the sequence. The first sequence will be G1. So I just assume that G1 the grade will be I think it's 7, I think, and then G2 will be let's say it's better than G1, and then start because this one will be the, just now I already mentioned, it will be the dependent variables, and then in here I already draw it up. So yeah, I already draw it up. You see that this one I already draw the column G3, so the S only be the G1, G2 study time and so on instead of G3. So let's say we don't need to write the G3 because we need to predict the GP. So the study time will be like, let's say 3 hours. The failures will be, I don't think we got the failures, the essence, just essence one. No, so just print the predictions. So let's see the output. What's the result get? Wait, sorry, my names. I think I typed the wrong names. Okay. So the output will be 7.1. The final semester 3 grade will be 7.1 in here. So not very bad, I think. So okay. Hello, I think we still got a few ties. So let me show you one more things. Let's say in here we face the one-man problem. For example, like if you quit this project and you join again, every time you need to run this everything code again. Even though it only took just a few or only 1 second to run everything code, but in the reality reality, the all the data set will be, it will be like 10,000s or even millions of the data sets. So if you face if your data sets will be more bigger, the more time you need to run this code. So it may be like for example, you need some maybe 10 minutes, or even the worst will be needs 1 hour. So in here we got one solution to solve this problems and help our to save our time more better. So what you need to do is from the sklearn, what we need to do is now is we need to save this module. So in next time we just directly open this module without restart all the things again. So what you need to do for sklearn.external, import the job lead. So yeah, sorry, I think I already write it down. So yeah, then let me use this one. So for the job lead, what you need to do is job lead.dump. Just put the file into this one. So dump. So because our module already fit the X train and Y train, all the data. So we just model. Okay, and then we just create our own file. The file name will be whatever you want. For example, I want the student grade 3. Remember to put the job lead, the file format of the file. So after that, you already set the job lead up. So the file name will be student grade.job lead. So what you need to do is, let's say if you want to open, you just create a new variable, for example model 1. So job lead dot log. You still need to log this okay. So just use this file name, Control C and Control V. So, and then yeah, so for example like just print okay. Well, you already saved all the things, and then you can open this one. Model 1 will belong to the previous model. So for example, ACC, I think we just copy and paste ACC dot score st. So will not be any error lah. Model 1 dot score. So print the ACC first. Just test it got any error or not. Yeah, don't have any error. So when you see that it directly load this file and then directly write the code without need to log all the things all the code again. So save tons of your times if your data set is very bigger. So that's all for today's lessons. In next lesson, I will teach you another classifications algorithm in machine learning. So just stay tuned and subscribe me for motive me. Thank you everyone.